guys, this is Mrs. Rona with another mini lesson on a net ionic equations. Now this is definitely balancing equations on steroids. So when I look at this, I've got silver nitrate, and we don't write the Roman numeral for silver because he's always silver 1. But I'm going to write the elements above him so I can do crisscross method and then figure out what his actual compound is. So there's silver with a +1 charge, nitrate's a polyatomic ion, NO3 with a -1. So when I crisscross these guys to form its compound, it's going to give me AgNO3. Now this is going to be an aqueous solution. And I'm going to go ahead and show you the solubility rule so you know how that's working. So I look at over here, magnesium, he's got a +2 charge, and iodine's got a -1 charge. So same thing, crisscross. And I'm going to have Mgi2, and he's also going to be in an aqueous solution. So if I go and switch over to my simple solubility rules, and I know I'm doing it kind of weird, but it's okay. You guys love me. And so here is off of your Schoology page. When I look at my nitrates, it's going to tell me most nitrates are soluble, which means they dissolve in water, so they're aqueous. So that's why I know he's there. Now I look at the next one right here where it says most chlorides, bromides, and iodides are soluble. The exceptions are with silver, lead, and mercury 1. Well, it's magnesium, so he's also soluble. So that's how I know they're both soluble in water. So I'm going to go ahead and put AQ on there. Now, if you remember from the previous mini lesson when I was talking to you guys about the double displacement reaction, this is where you had that scandalous thing going on, where you have these elements who are going to be mixed matching and hooking up. So basically what's going to happen is nitrate and magnesium are going to get together, and then you're going to have silver and iodine hook up. So those guys are going to get together. So all I'm going to do is I'm going to kind of rewrite them over here to form its compound. So I have Ag with a +1 charge, and I have iodine with a -1 charge. When these guys crisscross, I'm going to form AgI. Well, the next one is going to be magnesium and nitrate. So I'm going to have Mg with a +2 charge, and I'm going to have nitrate with a -1 charge. Okay, these guys are going to crisscross, come here, come there. So I'm going to end up with Mg parentheses NO3 parentheses close 2 plus Mg parentheses NO3 2. Okay, so that's going to be what I'm going to be producing. Now, to figure out if it's going to be a solid or an aqueous solution, I'm going to come back to my rules right over here. So the very first one with the iodine, that's rule number 3 right here. Most of them are soluble, exceptions of silver, lead, and mercury. Well, you notice I have silver 1 iodide or silver iodide. So that means he's not going to be soluble. So that means he's going to produce a solid. So I'm going to go ahead and put an S on that compound. Looking at the other one, which is magnesium nitrate, back here, most nitrates are soluble. All right, so that means this guy is going to be dissolved in water. So I'm going to put AQ in here. He's soluble. And this one's going to be the precipitate that's going to come out of my double displacement reaction. All right, so there's my molecular equation. Now, just like normal, you want to balance the equation. I'm going to do it just simple up here without doing the T-chart. So I have 1 silver here, 1 silver. That's good. I have 1 nitrate, but I have 2 nitrates over here. That's not balanced. So I'm going to have to go and put the coefficient of a 2 over here. So now that messes up my silver. Because now I have my 2 nitrates. Great, but now I have 2 silvers as well. So I'm going to put the coefficient of 2 over here. So that gives me my 2 silvers. That gives me 2 iodides, but you notice you have 2 iodides there. So that guy's balanced. So that just fixed that problem without even looking at it. I've got 2 nitrates here. I got the 2 nitrates here. I got 1 magnesium, 1 magnesium. Perfect. That one's done. So now, when looking at this, anything that's going to be an aqueous solution, it's going to disassociate into its ions. So basically, I'm going to look at, I've got silver ions here. I've got nitrate ions here. I've got magnesium ions. I've got iodide ions. This one's not going to disassociate. So I'm just going to write them as such. And this guy's going to disassociate. So I'm going to have magnesium with a +2 charge plus nitrates. Now, keep in mind that the coefficients and the subscripts are very important. When I look at this, I have 2 silver nitrates. So I need to use that coefficient to represent how many ions I have. So I'm going to have 2 silver ions plus 2 nitrates. Okay, I'm going to have 1 magnesium, but because the subscript tells me I have 2 iodines, I'm going to have 2 iodine ions. Plus silver iodide is a solid, doesn't come out, and I'm going to have 1 magnesium, but I'm going to have 2 nitrates. So that is going to be my ionic equation. I'm just going to write it down here nice and clean. So I have 2Ag plus 2 nitrate ions plus magnesium ions plus 2 iodine ions reacts to produce 2 silver iodides, that's solid, plus magnesium ion plus 2 nitrate ions. Okay, so that is going to be my ionic equation. My net ionic equation is pretty simple. I'm going to see what's on the reactant side, and if I find it on the product side, I'm going to exit out. So if I have 2 silver ions here, I don't have any silver ions in there, so that's going to stay. I have a little check mark here. All right, to make sure that I've gone through everything. If you notice, you have 2 nitrate ions here, but I have 2 here. So I'm going to X these guys out because they're going to cancel each other out. I come here, I have magnesium with a +2 charge. Oops, little mistake. All right, so this is with a +2 charge, my bad. So this one is right here, and that one is here. These guys are both on the reactant side and the product side. So these guys are going to cancel each other out. And you notice you have the iodine ions, but not on that side. So all I'm going to do is I'm going to write out what I have left. So this guy stayed, and this guy stayed. So only my check marks is what I'm going to write down during my net ionic equation. So I'm going to have 2Ag plus, keep going, here's my next one, plus 2 iodine ions reacts to form 2 AgIs, 2 silver iodides, and it's going to be a solid. Now this one's kind of cool. He's kind of a special guy. Because if you notice, I have 2, 2, and 2. So I can actually reduce them down. So that's what you need to do. Reduce them down to its lowest coefficient numbers. So I'm going to do 2, 2, 2. So his final answer is going to be silver ions plus iodide ions goes and forms silver iodide. There you go. Now this is definitely one of their fan favorites for the AP tests. I'm going to do 2 more up on the board for you guys to kind of get the hang of it. Alrighty guys, so let's go ahead and try another one here. Let's go ahead and do nickel 2 nitrate and sodium hydroxide. So once again, I'm going to go ahead and put these words into its compound formula. So I'm going to look at nickel 2, that means it's Ni with a +2 charge. Nitrate is NO3 with a -1 charge. Sodium is Na with a +1 charge. And hydroxide has a -1 charge. Okay, so I'm going to crisscross method. This 2 is going to shoot over here. This one's going to come over here. So I'm going to have nickel, parentheses, nitrate, the 2, plus sodium hydroxide. Okay, both of these guys are 1, so I don't need any parentheses over here. So that's going to be on my reactant side. So now here comes that scandalous relationship again. So nickel is going to hook up with hydroxide. So these guys are going to get together, and then these guys are going to get together. So to go and form my compounds here, I'm going to have sodium with a +1 charge, and then I'm going to have nitrate with a -1 charge, NO3 with a -1. So criss cross. So I have sodium nitrate, and then I'm going to do the same thing with my nickel 2. So I have nickel with a +2 charge, and I'm going to have my hydroxide with a -1 charge. So criss cross, I'm going to have nickel 2 hydroxide, parentheses closed. Okay, so that's going to be my molecular equation. Now I need to go and balance it. So I look at it, 1 nickel here, 1 nickel there. Good. 2 nitrates here, 1 there. Put a coefficient of a 2 there. Okay. So now I have 2 sodiums. I have 1 here. Put a coefficient of 2. It gives me 2 sodiums. That fixes that problem. 2 hydroxides, 2 hydroxides. Perfect. That was an easy equation to balance. No big deal. Well, let's go ahead and look to see who's aqueous and who's not. Well, if you remember from your rules, it's kind of coming right back here. It says most nitrates are soluble. So nickel nitrate, he's aqueous. My sodium nitrate, he's also aqueous. I look at my sodium hydroxide. That's going to be the rule number 5. Most hydroxides are slightly soluble. Most important ones are sodium hydroxide. All right, continuing on. I paused it so y'all wouldn't hear the announcements. It was all about lunches. All right, so now I'm looking at the nitrates. So most of them are soluble. So sodium nitrate was soluble. The next one I was looking at was nickel hydroxide. And it says most of them are soluble. The important ones are sodium hydroxide and potassium hydroxide. Okay, and then these are going to be marginally soluble. Okay, so this guy is also going to be soluble. Okay, coming back. Now, just doing a little bit of research on nickel hydroxide. He does fall under that slightly soluble, and it's not really very soluble. So there's going to be a precipitate that comes out. So he's kind of one of those exceptions to the rules. So he is a solid. Okay, so he will not disassociate. All right, so now I'm going to go ahead and break down my nickel nitrate. Oh, I forgot. Sodium hydroxide is also aqueous. Okay, so he was one of those notable soluble compounds. All right, so I'm going to write these guys down into its ions as they will disassociate. So I'm going to have nickel with a +2 charge, and I only have 1, so I don't have to do anything special. Plus, I've got 2 nitrates. They're going to split out. I'm going to have 2 sodium ions. And I'm going to have 2 hydroxide ions. They're going to react to produce. And once again, my sodium nitrate will split up. So I'll have 2 sodium ions plus 2 nitrate ions. And then nickel hydroxide, because he is a solid and he's going to precipitate out, we're going to write him out as such. Okay. Wrong way. There you go. So you can see the whole screen. All right. So there's my Ionic equation. Now you will cancel everything that matches. So I have nickel ions here, but it's in compound. This guy is going to stay. So I'm going to write this guy down. So I have nickel with a +2 charge. I have 2 nitrates here, 2 nitrates there. This will cancel out. I have 2 sodiums here, 2 sodiums there. That will cancel out. So now I have 2 hydroxide ions, and this will react to go and produce nickel hydroxide. And there's my final answer. We go ahead and do one last one. Hopefully it'll clear up any questions that you have. I know this is balancing equations on steroids. Alrighty guys, so last problem, lithium hydroxide plus barium chloride. All right, so the symbol for lithium is going to be Li with a +1 charge because he's an alkali metal. Hydroxide is OH, also with a -1 charge. This is why I told you guys, y'all had to memorize your polyatomic ions. They should just come naturally. Barium, he's an alkaline earth metal with a +2 charge, and chlorine is a halogen with a -1 charge. So once again, criss cross. So I have lithium hydroxide plus criss cross plus barium chloride. This is going to go and react to go and produce. Here's the scandalous part. All right, so you'll have lithium and chloride hook up together, and then you're going to have barium and hydroxide hook up together. All right, so I have lithium with a +1 charge, chlorine with a -1 charge. That one's easy, just LiCl. And then I got barium with a +2 charge and hydroxide with a -1 charge. So that would be barium hydroxide. Okay, so that's kind of how those guys mix match. I'll do it off to the side just in case if you're still kind of confused on how that's coming together. So I had Li with a +1 charge, chlorine with a -1 charge, crisscross, LiCl. The other one was barium with a +2 charge and hydroxide with a -1 charge. Crisscross, Ba parentheses OH2. Okay, so that's how those guys came together. So now I'm going to go to my rules of my solubility chart. Here we go. So I look at the very first one, lithium hydroxide. So right in here, back to the rules, most hydroxides are slightly soluble. But I'm going to jump over to here, number 2. Most salts contain an alkaline metal, which is lithium, and ammonium are soluble. So because of that, lithium hydroxide is soluble, so he's aqueous. Barium chloride will fall under rule number 3. Most chlorides are soluble except silver, lead 2, and mercury 1. So he's also aqueous. Now, the next one, lithium chloride, same thing here. He's going to be soluble. So he's going to be aqueous. And then I look at the last one, which is the hydroxides, barium. So it tells you right here, specifically, barium hydroxide is marginally soluble. So he is soluble as well. All right, so that's how these guys are going to work. So now coming back to the board. So now I'm going to go ahead and balance out my equations. I have 1 lithium here, 1 lithium there. Cool. 1 hydroxide, 2 there. So I'm going to put a coefficient of a 2 here. Okay, so now I have 2 lithiums, but I only have 1, so I'll put a coefficient of a 2 here. So 2 lithiums, 2 lithiums. 2 chlorides, I've got 2 chlorides. Beautiful. 1 barium, 1 barium. 2 hydroxides, 2 hydroxides. Whew, the easy part of this. Now, if you notice, all of them are going to be aqueous, so they're all going to disassociate. So I'm going to go ahead and write them down. I've got 2 lithium ions plus 2 hydroxide ions plus 1 barium ion plus 2 chlorine ions reacts to go and produce 2 lithium ions plus 2 chlorine ions plus 1 barium ion plus 2 hydroxide ions. Okay, so all I did was break them down into its ion. They'll disassociate into its charges. So now it's just canceling. What do I see on both sides? I have 2 lithiums here, 2 lithiums there. I have 2 hydroxides here, 2 hydroxides here. That cancels out. I got barium ions here and 1 barium ion. That cancels. I got 2 chlorines, 2 chlorines. Wait a minute. It's all gone. All right, and that is very possible because they're all spectator ions. Okay, so that would be your answer. All spectator ions. So just kind of want to throw it out there. You won't always have a net ionic equation. If they're all soluble and there's no precipitate that comes out, you will not have a net ionic equation. Okay, so all these guys are spectral ions and cancel each other out. Alrighty guys, so yes, definitely very different balancing equations. Like I said, this was balancing equation on steroids. If you got any questions, please do me a favor and send me a message through Schoology or through Remind. Love you guys. Good luck. I hope this helped you understand a little bit better. All right, good luck.